Hi students, welcome to section 3.4, the quadratic formula. Alright, so the quadratic formula is the formula you see here. It's a formula that is used to find the x-intercepts or the zeros. So you're finding the roots of the function. Whenever you can't factor, this is what you're going to use to solve for the zeros. Alright, so examples. Find the roots of the following equation using the quadratic formula. And don't forget what these come from, these b, a, and c and stuff like that. This is coming from x equals to, sorry, not x. This is coming from 0 equals to ax squared plus bx plus c. Okay, so you're looking at the coefficients a, b, and c inside of that, which you're going to solve when that's equal to 0. Alright, so in this case, find the roots of the following equation using the quadratic formula. So we're going to use what we have here. The value of a here is 1. Okay, so the number in front of the x squared is 1, so your a is equal to 1. The number in front of the b is -5, so b is equal to -5. And c is 6, which is the constant, correct? So positive 6. Okay, so again, they match the values given here. Okay, so I'm going to plug those into this formula to actually solve this equation. So in this case, what we're going to have is we're going to have x equals to -5, right? So the answer here is negative b, and b is -5, so -5, right? Plus or minus square root of b, which is -5, squared, minus 4 times a, which is 1, times c, which is 6. Okay, divided by 2 times a, which is 1. So I'm just going to make sure that's clear here. So you have squared here and then minus. Okay, so then you basically just solve that. So expand this completely. See what this is? So this is -5. So you have x equals 5 plus or minus. And here you have square root of this number here, which is square root of 25 minus 5 squared minus 4 times 1 times 6, which is 24. So 25 minus 24 is 1 over 2. 2 times 1 is 2. So notice this plus or minus here. This plus or minus means there are two different possible solutions. What you have here, okay, so I'm going to write up both separately. You have x equals to 5 plus the square root of 1, which is obviously just 1. So 5 plus 1 over 2. And you also have 5 minus square root of 1, which is 1 over 2. So here comes the two solutions, very much like what you had when you solved quadratic formula. And you had two solutions. So here you have 6 over 2, which is 3. And here you have 4 over 2, which is 2. And here are the two solutions to this problem. Okay, well, that made it a lot harder than it used to be, right? Because if you looked at this carefully, so note, was the trinomial factorable? Absolutely. So yes, it was. Okay, so if I was to factor this out, so x minus 3, x minus 2 equals 0, you'd have x equals 3 and x equals 2. So this was basically just a long way to get to the same solution. However, when it's not factorable, you don't have a choice. But when it is factorable, I would recommend you try to factor it. Alright, so here's another example. So again, we're going to look at it and we're going to see, hey, can I factor? Because that should be the first thing you look at. And no, you cannot factor this because two numbers multiplied to 2 and two numbers multiplied to 1 is 1, and here's 1 and 2. You'll never get a -10 in the middle. So this is a quadratic formula, which you got to use. Alright, so you're going to identify your values of a, b, and c. So in our case, a is equal to 2, b is equal to -10, c is equal to 1. And then you're going to solve, plugging in the values inside that lengthy formula. So here it's x equals to -10, right? So negative b, plus or minus square root of b, which is -10, squared, minus 4 times a times c. And then the whole thing, so notice that often a common mistake is just dividing the square root. No, the whole thing here is divided by 2 times a. Whoops, didn't mean to change colors here. 2 times a, which is 2. Alright, so then you're going to simplify this completely. So if there's two negatives here, you'll always change this to a positive. And over here, you're going to completely take out the square root. So you have negative 10 squared, which is 100. 100 minus all that multiplied is 8. So what you have left is x equals to 10 plus or minus square root of 92, right? Because this is 8, this is 100, divided by 2 times 2, which is 4. Okay? So here, if you're looking to sketch this or put this in your graph, what you're probably looking at doing is taking out your calculator and plugging in the two values. Because notice here, this is a case where this wasn't factorable, and therefore this number here isn't a perfect squared. On the last question, the perfect square, 1, turned into 1, so you could get rid of the square root. In this case, because it's not a perfect square, this is a hint that you could not have factored this question at all. Alright, so now we get to the simplification part. So what you're going to want to do when you answer these in simplified form, you're going to try to simplify this as much as possible. The way we're going to do that is we're going to take the square root of 92, and you're going to try to find factors that are perfect squares. So a factor of 92 that is a perfect square is 4. So it's square root of 4 times square root of 23. Multiply those together, you get 92. And the square root of 4 is 2. So you have 2 square root of 23. So that's how you're going to simplify this term right here. So you have x equals to 10 plus or minus 2 square root of 23 over 4. Okay, well, this can continue to be simplified by the fact that notice that on the numerator we have a common factor of 2. Okay, so this is 10 plus 2 square root of 23, 10 minus 2 square root of 23. So they each share a factor of 2. So what we're going to do is we're going to factor out this 2, and on the numerator we're going to have 5 plus or minus square root of 23 over 4. So notice that if I was to distribute this 2 into both terms, 2 times 5 is 10, 2 times 2 square root of 23 is, well, exactly 2 square root of 23. So by doing this, now I have a factor of 2, and notice the denominator is a 4, which also has a factor of 2. So these two terms can cancel out, and what we have left is here. So now you get this, you get 5 plus or minus square root of 23 over 2. So again, if you want the decimal value of this, all you got to do is take out your calculator and you plug in these values, and what you're going to end up getting on one side, so let's say the positive side. So when I say the positive side, I mean the 5 plus square root of 23. So you're going to plug that in your calculator. This is approximately equal, sorry, I'm using the other symbol. This is approximately equal to 4.8979. And on the other side, it's equal to 0.102 and 1. I'll round to that fourth decimal. Okay, so what you have here, these are 2 points on your graph. So if I was to sketch a graph, just to understand what's going on here, if I was to sketch a graph, you would have 1 point, 1, 0 at 0.01, so really close to the origin there, and 1 at 4.89. And that would be the 2 zeros of your graph. Alright, so again, another slightly different example. What you have here is you have an expression, and an equation, where it's not equal to 0 on one side. And it is absolutely important that whenever you use the quadratic formula, you have equal to 0 on one side. So what I'm going to do is I'm going to expand this, make it equal to 0 by bringing that over, and then have something for a, b, and c. So the first thing I'm going to do is expand these two terms here. These are conjugates, which makes this a difference of squares. So when you multiply them through, it's pretty easy. All you get is x squared minus 1, because the term in the middle goes away. And now we have 2x equals to 3x squared minus 3, because you distributed the 3. And then I'm going to bring this 2x over here, and what you have is 0 equals to 3x squared minus 2x minus 3. Alright, well, with this expansion, now I have a value of a, b, and c. So the value of a would be 3, the value of b would be negative 2, the value of c would be negative 3. And for the purpose of this exercise, we're just going to not try to factor, and we're going to actually just use the quadratic formula. Okay, so I'm going to plug in the values, probably go a little bit faster this time since it's just repeating the same work. So I'm going to have x equals to negative 2 plus or minus square root of negative 2 squared minus 4 times a times c. Okay, this is a formula you'll be given, so you don't have to memorize it, and divided by 2 times 3. Okay, so here you have negative 2, which is 2, plus or minus, so this is 4, and then here altogether this is 9 times 4 is 36, 2 negatives is a positive, so this is 4 plus 36, which is the square root of 40, and that's divided by 6. And over here, now I can simplify this square root of 40. Okay, so again, I'm using the same logic as I used last time. Again, 4 is a perfect square, it's 4 times 10. So I can write this as 2 plus or minus 2 square root of 10, because don't forget the square root of 4 is 2. And then all that's divided by 6. I'm going to use the exact same strategy last time again. We have a common factor of 2, so I'm going to take out that common factor of 2. What you're left with was 1 plus or minus square root of 10 over 6. So now you have a common factor here of 2 and 6. You can cancel those out. So this is 1 and this is 3. And your final answer, simplified version, is 1 plus or minus square root of 10 over 3. Again, if you want to break these up into two different answers as 1 plus square root of 10 over 3 and 1 minus square root of 10 over 3, that could be a possibility. And also if you're graphing these, most likely is you're going to put these inside your calculator to get a little bit of decimal value. You can always approximate the square root of 10. Alright, last example. Notice that here you have an equation with fractions involved. I would recommend, if you have an equation with fractions, you would get rid of the fractions first. You can do this problem with fractions. It just inside the quadratic formula you might be working a little bit harder than you have to. So to get rid of the fractions in an equation, you just multiply by the common denominator. So in our case we're multiplying each side by 6 because the common denominator of fractions is 6. Alright, and next step we're just going to basically multiply this in. So this 6 divided by 3 is 2. So you have 2 times 2x squared. So you're going to have 4x squared. There's no denominator on the 1, so you just multiply the 6 times the 1, which gives you 6. And here the 6 divides the 6 and cancels itself out, so what you're left with is 5x. Okay, so again you want equals 0 on one side, so I'm going to move this over here. So what you're going to have is 4x squared minus 5x plus 6 equals 0. And now your values of a, b, and c are all figured out. And from this point on, it's basically just repeating the exact same work we was doing before. So x equals to negative 5 plus or minus, that's negative b, square root of b, which is negative 5 squared, minus 4 times a times c, so I'm just associating those with values, divided by 2 times a. Alright, and then, so again, we're just expanding this work. So you have x equals to negative 5, which is 5, plus or minus square root. So again, you're going to do the work inside here. So this is 25, and this is 24 times 4. So notice that the value here is negative, and this total here is 96. So you have 25 minus 96, and divided by 8. Okay, this should draw up a red flag here, guys. The reason is 25 minus 26 is negative 71. Well, you cannot take the square root of negative 71. So we're going to write that. So cannot take square root of negative 71. Therefore, what happens is there are no zeros. So no solution to this problem cannot take the square root of a negative. And this means that there are no zeros. And you can just imagine what a graph with no zeros look like. So here, if I was to sketch a graph, here's a parabola that has no zeros because I'm not crossing the x-axis. Another different graph would be this one. Again, I am not crossing the x-axis. So this is what it's telling you, is that by saying this, it's saying we never cross this line on the graph. All right, good luck with the lesson, guys, and hope you enjoyed the lesson.